Hello again. What we're doing in 7.6 is we're looking at rational equations. And this is actually going to be our last section of Unit 3. There was supposed to be another one, but we crossed that out for the sake of time and with our semester kind of losing a week in there. So we got rid of 7.7. So this will be our last one. What we're doing now is solving equations, something that you're all very familiar with. The only difference now is we have not just variables in them because equations always have variables, but now our variables are located in the denominator. So we have to address this a little bit differently. The first one I'm going to look at is example 1. Now this one is something that you would have solved maybe in Math 005. You could have solved this one before. There isn't anything new in this equation because of the placement of the variables. You'll notice how in this one, the variables do not fall into the denominator at all, whereas in number 2, they are in the denominator, and you'll see them in the denominator in all your other problems. We're going to go through number 1, though, just as a review of how to solve these. The first thing, and we're going to look at the steps up top. The first step, list any restrictions that cause the rational expression to be undefined. Well, these denominators, nothing has a variable, so there isn't anything that would cause this to be undefined. So we're not going to worry about that step. The next one, clear fractions by multiplying both sides by the least common denominator. So this is the idea of clearing fractions. So we need to find the least common denominator. We have a 4, an 8, an 8, and a 4. That means the least common denominator here would be 8. That's a number that all those denominators go into evenly. So now we need to distribute the 8 or multiply an 8 by both sides of this. So we can think of, okay, we need to take all of this and multiply an 8, and then take all of this and multiply an 8, which means we will be distributing an 8 to every single term in this equation. So I'm going to write it a little bit nicer. So we have 3/4 x times 8 minus 5/8 times 8 equals 3/8 x times 8 plus, and I scribbled over, I think that's a 7/4 times 8. Now the idea here is when we multiply all of these, the fractions will get cleared, which is how we know that we chose the right number. If you're not clearing your fractions, then you made a mistake somewhere. So the first one, 4 goes into 8 2 times. 2 times 3x is 6x. And then we have minus. 8 goes into 8 1 time. 5 times 1 is 5. Equals 8 goes into 8 1 time. 3x times 1 is 3x. And then we have plus, and then 4 goes into 8 2 times. 2 times 7 is 14. So that would be the second step up here. Well, we cleared both sides. And then the next step, the third one, solve the resulting equation for all solutions. So now we have to solve this. So we subtract a 3x from both sides. So we're left with 3x minus 5 equals 14. Next thing we have to do is add a 5 to both sides. So we get 3x equals 19. Divide both sides by 3. We get x equals 19 over 3. And then what you should do then is then check all solutions into the original. So what I want you to pause the video, use your calculator, substitute 19/3 in for the x to make sure this is true. I checked it on my calculator. I will let you check it to see if we made any mistakes or not, so you can see if 19/3 is correct. But I want you to go back and check it to see if that is correct or see if we made any mistakes. Number 2, we have 1 over 3x plus 1 over x equals 4/15. Again, the first thing we have to do is list any restrictions that cause any of the rational expressions to be undefined. So we want to look at each of these denominators, 3x, x, and a 15. What value could we substitute in for x that would make the denominator go to 0? If you need to think of it, 3x equals 0, solve that. Which you divide both sides by 3, you'd get x equals 0. So that means if you substitute a 0 in for that, it would go to 0. Same thing with this one. If you put a 0 in for x, obviously it's 0. So here the restriction would be 0, and that would be the only restriction. There's nothing to substitute in for x that's going to cause a 15 to become 0. So here the restriction, or you can see in the note above, we call these, so this would be, so restriction would be 0. That means that we cannot have an answer as 0. And we'll get to the extraneous solutions here in a minute. So now what we have to do is identify what the least common denominator is going to be. Well, we have a 3x, an x, and a 15. Well, we know it has to be a 15 because 15 is the least common denominator between a 3 and a 15, and then you see an x here. So the least common denominator is going to be a 15x. So again, we have to multiply everything by this 15x. If you do not choose the correct denominator, not everything will cancel out nicely and you won't clear your fractions. And then we have this 4/15. Do not forget to multiply the 4/15 by the least common denominator as well. Now we cancel. 3x goes into 15x 5 times. 1 times 5 is 5. And then x does not go into 15. Oh, that should be a 15x there. 15. Let me just change this a little bit. That should be 15. Here, I forgot my x over here as well. Sorry about that. This should be 15x and 15x. There we go. Now this will work better. X goes into 15x. The x's cancel. 1 times 15 is 15. Equals. The next one, we have 15 goes into 15 one time. And then we're left with 4 times x is just 4x. And then we just need to solve this. So if this would be 20 equals 4x, divide both sides by 4, divide by 4, divide by 4, we get 5 equals x. And then we want to substitute that in to check to see if it's correct. Again, I want you to pause the video and check to make sure it is correct. When you check 1 and 2, you'll notice that they both work. But you want to make sure you can do that on your own as well. Okay, so I'm going to skip number 3. I'll let you try that one on your own. But let's go ahead, or actually, I'll just at least get you started on number 3, and then I'll let you finish that. So the only thing that's really different about 3 is we have some that are not fractions. So if you need to, for one like number 3, fill in some denominators. This would be x over 1. This would be 5 over 1. So here you would see your least common denominator would just be x. So you'd have to multiply an x by every single term. Again, I'll let you go back and finish that one. But now looking at number 4, what you'll notice is that the third fraction, or the fraction on the right, we have to factor that first. We need to factor that first before we can find the least common denominator. And we know this will factor into x plus 1, x minus 1. So therefore, the least common denominator for this problem is going to be that x plus 1 and the x minus 1, because here's the factor of x minus 1, here's an x plus 1, and this one has both. So both of them are going to be the least common denominator. So we need to multiply that least common denominator by all 3 of those. So we have 2 over x minus 1, and we're multiplying that by x plus 1, x minus 1, and then we're subtracting 5 over x plus 1 times x plus 1, x minus 1. I might run out of room here. Equals 4 over, I'm going to write the factored form, x plus 1, x minus 1. And we are multiplying that by the least common denominator, which would be x plus 1, x minus 1. We'll squeeze it in there, good enough. Now we can go ahead and do the multiplication, cancel things out. Again, the denominator should cancel. If they don't, you made a mistake. X minus 1, x minus 1. I'm going to do all my canceling first. X plus 1, and all of these will cancel. Now, when we multiply everything together, we have 2 times x plus 1. We'll have to distribute that. Minus 5 times x minus 1. We'll have to distribute the negative as well here. And everything canceled except for the 4 on the right. I'm going to pause the video. I want you to go ahead and finish this problem and also go ahead and finish 3 and then come back and check your work. Okay, looking back at number 3 to start with, we found our LCD to be x, so I multiply everything by x, and then I multiplied them. And now I'm getting a quadratic, meaning I have x squared. So I get, now this goes back to what we did in the last unit. Now we have to solve this equation, and I'm looking right here. We have to solve this. So just like we did in the last unit, we move this 5x to the other side, and then we have this, and we have to factor it, and then find our principal of 0 products, and we have x equals 7 and x equals -2. What we want to do is make sure neither of these are restricted values. So the only restricted value we have an x in the denominator would be a 0. And since neither of these are zeros, as long as you check your answer and they both work, then both of these would be your solution since neither of them are restricted. However, though, when we go to number 4, you can see that we multiplied the least common denominator by everything, and we're getting a value of x equals 1. We're getting a value of x equals 1. However, when we come up to here, if we were to substitute in a 1, 1 minus 1 would be 0. That means that 1 is one of the restricted values. Therefore, this x equals 1 is what we call the extraneous solutions because it's going to be excluded from the solution set. Therefore, since the 1 is excluded and there's no other values, then this problem is no solution. There is no value of x that would make this equation true because the only value would cause it to be undefined. All right, next page. Here we just have 6 examples. I'll work through one of them and then I'm gonna just pause the video and I want you to work through everything and then you can unpause it as you need to, look at the answers, look at the work, and then email me or whichever if you have any questions on anything. So let's see here. I will look at, I don't know if any of them are harder than the others. Maybe number 6. We'll look at number 6. 6 or 8. Well, actually, let's look at number 8. We'll look at number 8 together. The hardest part here is just going to be finding your least common denominator. In number 8, what you'd have to do is factor this denominator first. So whenever we have a trinomial, we know it's going to factor into 2 binomials. So this would be x plus 3 and x plus 1. So therefore, the least common denominator here is we need this factor of x plus 3. We need this factor of x plus 1. So this would be here, we have this whole denominator. This one is right here, and this 1 is just a denominator of 1, so that works as well. So now we need to multiply the least common denominator by every single term. From here, you can see that your restricted values would be -3 and -1. So if you want to, you can write, okay, restricted would be -3, -1. Again, you just want to keep those in mind in case we get to one of those values at the very end that you don't answer that as one of your solutions. So we have this 3 over x plus 3, x plus 1, and we multiply it by the least common denominator. Trying to write small here so we can fit this all in. And then this is going to be equal to 2 over x plus 1 and multiply this by the least common denominator. And then lastly, we have this minus 1 that you still need to multiply by the least common denominator, and I'm running out of room, so I'm just going to write it like that. The first one, on the left-hand side, we know everything's going to cancel, and we're just left with a 3 equals. The right-hand side, the x plus 1 cancels. We're left with 2 times x plus 3. And then we're subtracting 1 times, and then we have both of those. So now we have 1, and then it's going to be x plus 3 and x plus 1. And we have to distribute a negative to that. So then we have 3 equals 2x plus 6. And I'm just going to keep this subtraction here, but I'm going to put the parenthesis back because we haven't distributed that negative yet. And we know when we multiply this, we'd get x squared plus 4x plus 3. Now I'm going to distribute my negative. Again, you could have distributed the negative, the x plus 3. There's other ways you could have worked around that. Minus x squared minus 4x minus 3. Now, since my leading term here, this x squared, since that's a negative, I'm going to move all of that stuff to the other side, but I'm also going to simplify. So I'm going to do a couple, let's actually simplify first. So we'd have negative x squared, 2x and a negative 4x would be negative 2x. 6 minus 3 would be 3. Now I'm going to move everything to the other side. So add an x squared, and we're going to add a 2x, and then subtract a 3. Well, 3 minus 3 would just be 0, so then we're left there. Now we have to factor that, and I'm totally running out of room, so I'm going to come over here. So we'd have x times x plus 2 equals 0. So we get x equals 0 and x equals negative 2, and neither of those values are in the restricted list, so they would both be solutions as long as we didn't make any mistakes. So what I want you to do, pause this, go ahead, and we want to check both of those values into the equation to make sure that there isn't any mistakes. Okay, when you check those, you should see that both of those values are correct, so we know we didn't make any mistakes here. Now what I want you to do, I want you to go through, before we continue all these problems, I want you to go through 5, 6, 7, 9, and 10, and I want you to write 2 things down for each of these before you get into anything else. I want you to write the least common denominator for each problem and list any restrictions. We're just going to say rest. And list any restrictions for each. So I want you to do that. So least common denominator and any restrictions. So least common denominator and any restrictions. So I want you to do that for all of these problems here, and then unpause it, and then you can check yours with what I have, and then we can address any mistakes from there. So go ahead, pause it, fill those in. Okay, you can go through and check all your least common denominators and all your restrictions with mine. Again, pause the video, check it out. I'm not going to read through all of them. If you do have any questions on anything, again, just do a quick screenshot, send me an email, and ask where I found something. Now what I want you to do is I want you to pause the video and work through 5, 6, 7, 9, and 10. So this might take you a couple minutes, but I want you to work through these. Make sure you check all your answers. When you're finished, unpause the video and check to see how you did on it. I'm not going to go through each and every one and explain everything, but then you could then pause the video and go through problem by problem. Please do not just continue the video and then pause it and just write everything down. I'm not checking this work. You're not uploading it. This is solely for you to just get the practice on. So at this point, like I said, pause the video, work through all of these, and then see how you did with it. Okay, we have a lot going on here. So for number 5, looking at just number 5, I multiplied everything by my least common denominator. In the end, I get solutions of a equals 2 and a equals 3. Neither of them are restricted values, so they both are good. Again, you want to make sure you're substituting these back in the end to make sure they're correct. Number 6, we're getting a solution of x equals 18. Again, that's not a restricted value, so we're good with that one. Number 7, 9, and 10. Excuse me. 7, 9, and 10. I skipped the first step of distributing the least common denominator, writing it all out, only because I was running out of space. So for number 7, I did take the x and x plus 6 and I multiplied it by each of these. And then I just wrote out what I would get after I simplified everything. So this one, we're getting 2 solutions of x equals negative 6 and x equals 2. But we know that negative 6 is actually a restricted value here. So that means this cannot be. That would be an extraneous solution. Therefore, the only solution we have here is going to be this x equals 2. Number 9, I multiplied both sides by 4x. And when I simplified it, I get the 4x plus 2 plus x minus 3 equals 8x. Solve for x, and I'm getting an answer of x equals negative 1/3, which is not a restricted value. And number 10, the least common denominator we said was 4x squared, so I multiplied each of these fractions by 4x squared, and when I simplified, I got this. And then when I continued to solve, I get values of negative 2/3 and 2, neither are restricted values, so that's my solutions. So again, pause this, go ahead, look through it, make sure you don't have any questions. If you do, just send me an email and let me know what you have. Good luck on the homework assignment, and look forward to hearing from everyone.